All right, today we're going to be looking at the factor theorem. Okay, the factor theorem is part of 4.4. In 4.4, we did all of our factoring, and so the factoring theorem fits right in with this. Okay, and here's our core concept, the main idea of this. And what this says is that if you have a polynomial, oops, don't know why it did that. Let's see if we can undo that. There we go. If you have a polynomial, try and just use the highlighter maybe. Okay. If you have a polynomial, some function, and if x minus k is a factor of it, okay, then the number, whatever k is here, when you substitute it into the function, it better give you a 0. In fact, it has to equal 0. Okay, so kind of in the reverse of that, if the k of 0, this would be the converse of it. So if you substitute in k for the x value in your function and it equals 0, then x minus k is a factor of that function. So let's look at a question here, and then we will see how we could solve it using this factor theorem, and then we'll look at other ways we can actually solve it. So here we have a function, f of x equals x squared minus 3x plus 2. The question is x minus 1 a factor of it? And the factor theorem says if I substitute in the number 1, note how we use the opposite sign because it says x minus k, therefore k is the 1 here. So if the f of 1 is 0, then yes, x minus 1 is a factor. So what we're going to do on the next slide is we are going to find the f of 1. So here we go. Again, I've got my function here. Let's see if it'll write now correctly. I got my function here, x squared minus 3x plus 2. Okay, I want to find the f of 1 and see if it equals 0. And so all I have to do, as you can see it right here, is I'm going to find the f of 1. So every place I see an x, I'm going to put in the value 1, and I've done that. You can see right here, there's an x. I've replaced it with 1. Then comes the minus, the 3, the 3. There's an x. I've replaced it with 1 using parentheses. When I replace it, then our plus 2. So it's the same function, except for x has all been changed to 1 to calculate what the f of 1 instead of the f of x is. Okay, so we have to take care of exponents first. So we'll square it, and then we do some multiplications, giving us 1, and then negative 3 times 1 is just negative 3. We add our terms from left to right, negative 2 plus 2, and that gives us 0. And therefore, it follows that factor theorem that if the f of your k value, in this case 1, gives you a 0, then x minus 1 is a factor. Now, this method works, but some of you have done this substitution method a lot, and you've seen how it gets very, very long sometimes. So let's look at a way that maybe will make a little more sense to us. Okay, we could use division to also figure out if something is a factor. Okay, for example, I'm just going to do a little simple division problem over here. If I divide 3 into 6, it comes out even. Remainder is 0. Therefore, 2 is a factor. Okay, if I take 3 and divide it into 5, it goes in there one time with the remainder of 2. And therefore, 3, I should have done it this way. I should have said 3 is a factor, but 2 would also be a factor. 3 is not a factor. Okay, so for it to be a factor, it has to divide into it evenly. So we can do, and you can see it right here, we could do a long division problem. Take the function, x squared minus 3x plus 2, divide it by x minus 1, and let's see if the remainder comes out to 0. If it does, then we indeed have a factor. So my first step is I'm going to multiply by x here. Okay, because x times x gives me that x squared. Of course, when I distribute this x, I also have to get this x squared minus 1x. So I distribute it. Notice we have the minus sign here because after we get done distributing x squared minus x, we have to subtract that. So it becomes x squared minus x squared, negative 3x plus, because that negative distributes, plus x. So here comes the subtraction, negative 3 plus that negative x, or plus x rather, comes out to negative 2x. And then we just bring down our next term, the 2. And then we ask ourselves again, what can I multiply x by to get negative 2x? So it's going to have to be a negative 2 that I distribute here. And we distribute the negative 2, and it's going to give us negative 2x plus 2, but we have to subtract that. Again, be careful there, because when you subtract it, it becomes plus 2x and minus 2. And hopefully if you can visualize that, you'll be able to tell that that adds up to 0. Okay, so that becomes plus 2 right there, and negative 2 plus 2 is 0. This becomes negative 2, and plus 2 minus 2 is 0. Again, this proves to us that we have a factor. If it divides into it evenly, you have a factor. So we've got two ways to test now. Way one, we could substitute in the k value and see if the remainder comes out to, or see if it equals 0. I'm just going to run through all these again. Way two, we could do long division and see if the remainder comes out to 0. But I would argue there is a third method that is the most efficient method, and it's the method you are going to want to use. See if it gets caught up here with us. There we go. Okay, remainder 0. Great, we have a factor. And faster than all of these is using synthetic division. Because we're just testing this binomial, this problem is made for synthetic division. Now be a little bit careful here. Remember, we always use the opposite sign of what's inside here. Since this is an x minus 1, we're looking for the f of 1. That was our first method. Or if we do synthetic division, we put a 1 in the box. All right, so let's do synthetic division and divide x squared minus 3x plus 2 by x minus 1. So we're first going to grab our coefficients here. So we grab our coefficients. It's 1, 3, and our 1, negative 3, and 2. And we're just going to line those guys up. Let's find the number we put in the box. Again, it's just the number 1 up here. This guy right here. And we're going to move him over there, and we'll put him in a box, skip a line, and draw a line. Now, for those of you who are still having a hard time with synthetic division, I do walk you through the steps here. Step number 1 is we just take that first coefficient and we drop it straight down. Most of us are doing a good job with that. Step 2, we multiply the number in the box times that number we just brought down. Okay. Throughout this little example here, what I've done is anytime you see that red arrow, that's a multiplication. Okay, so we're going to take 1 times 1. You take the answer to that and you put it underneath the next coefficient. Okay, so that blue arrow means this is where you put the answer to the multiplication. So right below that negative 3, we're going to just put a 1, the 1 times 1 we just did. And then the green arrow here means add. So we go negative 3 plus 1, and that's a negative 2. Now comes another multiply. Now we take the 1 times negative 2. Okay, that's negative 2. And we move it up underneath the last term. So 1 times negative 2, we put a negative 2 there. Lastly, we add those. And our remainder again is 0. And this is by far the quickest method for doing these problems. do synthetic division, see if the remainder is 0. If the remainder is 0, we say yes. No remainder, so x minus 1 is a factor. Now we're going to look at a few examples of these, and hopefully you'll see how quick we can do them. Okay, so I always start every presentation, it seems like, with the word okay. I will try to quit saying that, driving myself crazy. Let's take a look at how we can apply this factor theorem for a few examples here. So we want to show that x plus 3 is a factor of this polynomial. Okay, so here's method 1 we could use. And in method 1, we are going to find the f of, because this is a positive, we always use the opposite sign, f of negative 3. We could do that. Method 2, we could do long division, and it would look like this, x plus 3 divided into, and we'd have to put that whole polynomial down, or method 3, synthetic division. And so I'm going to use a synthetic division because it is by far the easiest. We still, when we're doing synthetic, we're doing this division problem, but this is just a shorter way to do that division problem. We put negative 3 in our box, always the opposite sign. Let's find our coefficients here. We have a 1 in front of that. Here's a 3. Here's a negative 1. And here is a negative 3. Okay, and it goes in descending order. No, it does not. We're missing 1. There is no x squared. So that's when we have to put in a 0. Okay, so we have one coefficient for each exponent that should be there. So we've got 1x to the fourths. We've got 3x cubes. We have no x squareds. We have negative 1 x's and negative 3. So if you're kind of keeping track here, this is our x to the fourth, x cubed, our x squared, our x to the first, and this would be our constant out here. And they always have to have all of these when you use synthetic division. Even if you do long division, you have to put them all in. And so here we go. We hope our remainder is 0. If our remainder is 0, then it is a factor. So we're going to bring down the 1. We're going to multiply right here. That's negative 3, and we'll add. Then we'll multiply. That's 0, and we'll add. Then we'll multiply. That's 0. It's negative 1. Then we'll multiply. Negative 3 times negative 1 is positive 3. Remainder is 0. And that is awesome because that's what we're trying to show. Is it a factor? How do we tell? If it's no remainder, that means it went into it evenly. And by definition, numbers that divide into other numbers evenly are factors. So we know that our function, f of x, equals x to the fourth, the original function. I don't have to put in the 0 now. I only had to do that when I was doing my synthetic. But I now know how it factors a little bit. It factors as the x plus 3, because it divided into it, and the answer down here. This was, now it's x to the third, no x squareds, no x to the first, minus 1. That is the other factor. Oops, x cubed minus 1. Okay, and this right here, remember, we always go down 1 degree, so it was x to the fourth. Now we're at x cubed. So you guys understand this. Let's say if I had done like just numbers, 3 goes into 12. How many times? We go 4. So here's what I divided by. Here was my answer. And 3 times 4 is 12. So it's equivalent to this. Okay. In this problem, here's what I divided by, the x plus 3. Here's my answer. So x plus 3 times x cubed minus 1 is its factorization. Now up here in our directions, it told us to factor it completely. So let's see if these two binomials we just found are factored completely. X plus 3, that is factored completely. We can't factor it anymore because it's x to the first power. This next one, however, is a difference of cubes. Okay, this is like an x cubed minus a 1 cubed. And so now we have to use the stuff we learned last week. Erase a little bit here. Remember, we had formulas for these. This one happens to be a difference of cubes. I'm going to do it off to the side just to help us remember. The difference of cubes is a minus b. Then remember it's the trinomial, so it's an a squared and a b squared, a little ab in the middle, and we've already used up our minus sign out front, so the rest are positives. For us, this is an x that's cubed and a 1, so every time I see a I'm going to put x. Every time I see a b, I'll put 1. So this is x minus 1, x squared, 1 times x, and 1 squared, which is 1 times 1, still 1. So that's what just this part equals. So our final factorization, the x plus 3 was a factor. Now x minus 1 is also a factor, as well as x squared plus x plus 1. And that is the complete factorization of that original polynomial way up here. Okay, now mathematically I didn't have to do a whole lot. We did some synthetic division. After I did the synthetic division, I used the difference of cubes. So that's not too bad. Make sure I didn't get it twice. Pull 2 here. I did. I don't know why that happened. Here we go. Determine whether x minus 3 is a factor of this. All right. All we have to do, we're dividing by a binomial here. Okay, so I'm going to use the opposite sign. I'm going to use a positive 3, and I'm going to do synthetic division. 1, 6, negative 12. 1, 6, negative 12. And we just do it. Here comes a 1, 1 times 3. Add them up. 9, 3 times 9, 27. Add them up, 15. This tells us, with a remainder of 15, x minus 3 is not a factor of f of x. It has to come out to 0. If it doesn't, we cannot factor that thing. Well, it doesn't mean we can't factor it. It just means that x minus 3 is not one of the factors. Last example, determine if x plus 3 is a factor of, look at the size of this polynomial, 2, 3, 5 terms in it. This would take us a long time if we did substitution or did long division. But we're going to use a negative 3 in our synthetic division box. We start with an x to the 4th, 2 of them. X cubes come next. X squared, just going by order of exponents, is a negative 1. That's not a 0 there, that's negative 1. And then lastly, a 6. So there's our 5 terms. And let's see if we get a 0 for a remainder. Multiply negative 6. Add. Negative 3 times 4, negative 12. Add. Negative 3 times negative 1 is 3. Add. That's 2. Negative 3 times 2 is negative 6. 0. Therefore, x plus 3 is a factor. We got a remainder of 0. And I'm going to say f of x. Okay, now we could break down f of x at this point. We could say, okay, so f of x is the factor we just found, x plus 3, times the answer to this division problem. Okay, we just start with 1 degree less. I was at x to the 4th, I'm at x cubed. 2x cubed plus 4x squared minus x plus 2. Trying to think, should we see if this thing factors a little bit more? Let's see if we can factor this guy. That's a 4-term polynomial. We talked about these on Friday. We'll just leave the x minus 3 hanging out here. Okay, and let's work on this guy. I'm going to group the first two together. I'm going to group the second pair. Now remember, we said on Friday, capture that negative sign. I could GCF this 2x squared, leaving me x plus 2. I could take a negative out of this one, giving us negative x minus 2. These two are not common factors. It does not look like we can factor that, at least with our knowledge and skill right now, anymore. So we can't factor it anymore because these did not match each other right here. They both have to be x plus 2's or x minus 2's. And therefore, if we are asked to factor it, we would be done right at this point. We don't have to go any further. Okay, and it didn't ask us to factor it. So for this problem right here, when it said, is it a factor, you'd say yes. That's all you'd have to answer. Of course, you have to show this work. You'd point to this remainder equals 0. So yes, it's a factor. That's it. All right, good luck with that. Homework shouldn't be too bad. You got 3 problems where you just have to determine if it is a factor, and then 3 problems where you try to factor it completely.